Hello and welcome to Statistically Speaking with Dr. Ilbayumi, where we turn numbers into knowledge. In this video, we will cover a beginner-friendly introduction to R and RStudio, powerful tools for data analysis and statistics. Whether you're in social sciences, natural sciences, or business, R and RStudio are invaluable allies in your academic journey. This video will cover what R is, what RStudio is, why they're used together, and what you'll learn next. R is a programming language specifically designed for statistical computing and graphics. Think of it as a highly specialized calculator and drawing tool with immense power and flexibility. Developed in the early 1990s, R is now a comprehensive statistical environment used worldwide. It's open source, free to use, and constantly improved by a global community. R excels at handling and manipulating data, allowing you to clean, transform, and perform vast statistical analysis. Beyond numbers, R creates high-quality, publication-ready plots and charts. One of R's greatest strengths is its packages, collections of functions that extend its capabilities dramatically. Over 18,000 packages are available, covering almost every statistical or data manipulation task imaginable. RStudio is the user-friendly dashboard that makes working with R easier and more intuitive. RStudio is an integrated development environment or IDE, providing an organized workspace for code, files, data, and results. The script panel is where you write and edit your R code, promoting reproducibility. The console panel runs your commands, displaying output, messages, and errors. The environment panel shows all loaded datasets, variables, and objects in your R session. The plots panel displays plots. The help panel accesses help documentation, and the files panel manages files. R and RStudio work together seamlessly, with RStudio enhancing the R experience for efficient data analysis. This powerful duo offers enhanced productivity with features like syntax highlighting and code completion. RStudio also allows you to create projects, self-contained working directories that keep your work organized. With RStudio and RMarkdown, you can integrate R code, output, and text into dynamic reports. This introduction is just the beginning of your journey with R and RStudio. You'll learn essential concepts and techniques. You'll learn to download and install R and RStudio, setting up your coding environment. You'll become familiar with each RStudio panel, understanding its purpose for efficient workflow. You'll start with R syntax fundamentals, including commands, functions, and the basic data types. A crucial skill is importing data from various formats like CSV and Excel files into R. Then you'll master data manipulation using packages like dplyr to filter, select, and transform datasets. You'll discover ggplot2 for creating stunning and informative data visualizations. You'll learn best practices for writing, saving, and executing R scripts for reproducible research. You'll explore R Markdown to combine R code, output, and text into dynamic documents. You'll learn to interpret error messages, troubleshoot issues, and develop debugging habits. Finally, you'll discover how to tap into the vast R community for help and continuous learning. Mastering these areas will give you the confidence to tackle data challenges and communicate findings. R and RStudio offer a vibrant, evolving ecosystem, making them invaluable tools for a data-driven world. In the next part of this video, we will explore the essential components of the RStudio interface and how to navigate them effectively. Please stay tuned. Before we dive in, let's take a moment to understand why the RStudio interface matters. When you are working in R, whether for data cleaning, statistical modeling, or visualization, efficiency depends heavily on how well you understand your development environment. A clear grasp of the RStudio interface allows you to write code more effectively, manage files systematically, inspect objects confidently, and to troubleshoot errors with precision. In this part, we will walk through the essential components of the RStudio interface and discuss how each pane supports a structured and reproducible workflow. While R is the programming language for statistical computing and graphics, RStudio provides a user-friendly interface that significantly enhances efficiency. It offers features like script editing, easy data and object access, comprehensive help functions, and project management capabilities. The RStudio interface is typically divided into 4 main panels, each serving a distinct purpose to streamline your workflow. In the top left, you'll find the source editor, your primary workspace for writing and saving R scripts. This is where you'll compose your code, add comments, and organize your analytical steps for reproducibility. Below that, in the bottom left, is the console panel, where R commands are executed and their output is displayed interactively. You can type commands directly here for quick tests or run entire scripts from the source editor. Moving to the top right, we have the environment and history panel, which helps you monitor all the objects you create during your R session. This panel also keeps a record of your command history, allowing you to easily recall and reuse previous commands. Finally, the bottom right panel is a versatile area encompassing files, plots, packages, and help. The Files tab allows you to manage your project files, while the Plots tab displays all your visualizations. The Packages tab is where you can install and manage R packages, extending R's functionality. And the Help tab provides access to R's extensive documentation and function explanations. Understanding these 4 panels is key to navigating RStudio effectively and maximizing your productivity. With this foundational knowledge, you're now ready to begin your journey into data analysis with R. Your next steps will involve loading data, performing basic manipulations, learning R syntax, creating plots, and utilizing various packages. This will build your confidence in using RStudio for powerful and insightful data analysis. Keep exploring, practicing, and leveraging RStudio's capabilities to unlock the full potential of your data. In the next part of this video, we will focus on R scripting essentials, how to write, organize, and execute scripts efficiently within RStudio. Please stay tuned. Before we begin, let's clarify why scripting in R is fundamental to sound statistical practice. Interactive commands may be useful for quick exploration, but reproducible research requires structured scripts. Well-written R scripts document your analytical decisions, ensure transparency, facilitate peer review, and allow your work to be replicated or extended with minimal ambiguity. In this part, we will examine the core principles of effective R scripting: file organization, coding conventions, annotation, execution strategies, and workflow discipline, so that your analysis remain both rigorous and reproducible. The R script editor is your primary workspace for writing, saving, and organizing R code, ensuring reproducibility and efficient project management. Unlike the R console, the script editor allows you to compose and refine your code before running it. This editor offers R-specific features like syntax highlighting and code completion, making your coding experience smoother. Code written in the script editor is not executed until you explicitly send it to the R console. You can run code line by line using Ctrl+Enter or Command+Return, or run the entire script with Ctrl+Shift+Enter or Command+Shift+N. Alternatively, the source button in the editor toolbar provides another way to run your entire script. The R console then processes these commands, displaying all output, warnings, and errors, providing immediate feedback. Saving your R scripts, which are text files with a .R extension, is crucial for preserving your work and making it reusable. To create a new script, navigate to File, New File, R script. To save, use File, Save, or File, Save As, giving your script a meaningful name. While RStudio autosaves, explicit saving with descriptive names is highly recommended for best practice. Now let's explore some best practices for beginners to build a strong foundation in R programming. First, always use the script editor for all important code to ensure your work is saved and reproducible. Second, comment your code liberally using the hash symbol to explain your logic and make your script understandable. Third, organize your code into logical sections using comments or blank lines to separate different parts of your analysis. Fourth, load all necessary packages at the beginning of your script using library to ensure all required tools are available. Fifth, maintain consistent naming and styling conventions throughout your code for readability and professionalism. Sixth, avoid hard-coded file paths. Instead, use relative paths or RStudio projects to manage file locations dynamically. Seventh, organize your projects in single directories to keep all related files together and simplify sharing. Eighth, start with a clean environment. Use rmlist equals ls to clear your workspace before running a script, preventing conflicts. Ninth, consider using version control systems like Git to track changes, revert to previous versions, and collaborate effectively. 10. Experiment in the console, but always save important code in your scripts. Scripts are for permanent solutions. Finally, use meaningful file names for your scripts to quickly identify their purpose without opening them. Mastering the R script editor and following these best practices will provide a solid foundation for effective, reproducible, and organized R programming. If you found this helpful, don't forget to like, subscribe, and click the bell to stay updated on all things data and statistics. Thanks for watching.